All right, so what we're going to do last here is we're going to do something called rationalizing the denominator. So I'm going to go back to that dividing. We're going to divide radicals. Now this works when we are dividing like radicals, once again, like roots. So it's a cube root and a cube root. Now the first way that we tried this was to write this as a single root. And then simplify that. The problem that we're coming into is that that's a fraction. If that happens, you're not going to go with this way. Instead, what we're going to do is we're going to do something called rationalize. So rationalize just means no roots in the denominator. All right, so I'm going to show you how we can do that and how we can rationalize this. And there's two ways that we're going to rationalize. One is this first way. So I've got this cube root of 9x squared y. I'm dividing it by the cube root of 2xy. All right. Now this first way that we're going to work with is I just have a single root in my denominator. I don't have anything being added. I don't have anything being subtracted. So in this case, we have a cube root. Now, the only way I can ever take anything outside of this root is if I have sets of 3. So instead, what I'm going to do right now is if I could multiply this by another cube root that has 2 more 2's, 2 more x's, and 2 more y's, then we have sets of 3 of each. I have 3 2's, I have 3 x's, and I have 3 y's. So now, what ends up happening for my denominator, I have 2 times 2 times 2, I have x cubed, y cubed. Now, if I changed my denominator, I have to do the exact same thing for my numerator. So 2 times 2, and I'm going to rewrite this. I'm just going to say x squared, y squared. All right. So now for my numerator, I'm going to multiply underneath the single radical. 9 times 2 times 2. I now have x to the 4th, and I have y cubed. From there, we're going to go ahead and do our simplifying. The denominator is actually pretty easy. I have 3 2's, so I have a set of 3. I have a set of 3 x's, and I have a set of 3 y's. X cubed means one set of 3. Y cubed means one set of y. So I have a 2, an x, and a y. So that becomes my denominator. Now my numerator, I want to try and simplify as best as I can. So what I'm going to do is I'm going to look at this 9. I'm going to break it up as 3 times 3. Now I'm looking at these values. I need sets of 3. I have 2 3's and I have 2 2's. I don't have a set of 3 with these values, with these numbers. So what I'm going to have to do is multiply all of these together. So 3 times 3 times 2 times another 2 gets me 30. That's 9 times 2 is 18. 18 times 2 is 36. Yeah, we're good. So that's 36. Now I still have my x term and my y term to try and simplify. Do I have a set of 3 with those x's? Yes, I have a single set with 1 remaining. With my y's, I have a y. I have 1 set of 3, so I can go ahead and write that as a single y with no x's underneath, with no x's or no y's underneath that radical, underneath that root. So we're at this point. This right here is not done yet. I need to simplify even more. So now what I'm going to do is I'm going to put my attention to what is outside of my radicals and see if I can simplify that even more. Now you can see that these x's actually divide out. These y's actually divide out. So now we're left with the cube root of 36x all over 2, and that is completely simplified. So that's one way that we can go ahead and simplify using this term called rationalizing our denominator, right? So that's one way. I'm going to show you another way in another video.